Hey everyone, it's what, 9:30, 10-ish PST, or as some of us think, it's 6:30 engineering time, 6:30 a.m. So really happy that you're all here and bright and early today. So yesterday, some of you must have heard how AI is really hyped up and so on. So clearly, if you thought AI is hyped up, let me tell you about another area around AR and VR, immersive computing, that's also kind of has like equal potential and equal hype. So I'm here to talk about both of them. So in the next few minutes, I want to give you a sense of, one, broadly how AI is used at Google, and specifically with a kind of a product lens, and how are the user problems being solved, what are the challenges and potential there. But then jump into specifically around immersive computing, this rich and in-context natural interface to computing with AR and VR and vision and voice, et cetera, and see what kind of opportunities and challenges exist there, and leave with a couple of food for thought. All right, so let's jump in. If the clicker works, probably doesn't. So we're in no danger of singularity. Like if the clicker doesn't work and video conference doesn't work in 2018. Are we just winging it? Ooh, okay. So I figured, I said, okay, let me think about distilling down to 10, 15 minutes. And I was like, first of all, those of you Cardi B fans, she said it best. I'm not involved with the hype. What I mean by that is I think there is a lot of kind of excitement and genuine potential in broadly AI, but also kind of thinking about this new interface to computing, et cetera. But there are a lot of challenges. We have a long way to go, and you'll hear me talk about specific examples here. Just level setting, and I think this audience is, I'll just zip through it, but I'm gratuitously using AI and ML, and those of you kind of who are prone to more precision in the audience are probably squirming in their chairs. Really, I mean, AI could be rule-based and like learning-based thing, but a lot of the breakthroughs and with deep learning and the excitement around products is around machine learning, thinking about instead of heuristics, teaching computers how to learn. There are many different methods, but they all roughly, if you squint your eyes, they look like, given this input, what is the best output? Yes, unsupervised learning is kind of, it's showing promise, but most of the examples on promise is from supervised learning, which means you have tons and tons of examples, which is why you have kind of the comment from the gentleman, Jesus, I think, this morning, who said from the unconference yesterday, which is, hey, data is really important, right? And then to state kind of the department of obvious, which is like, hey, why now? We've been talking about ML, and so many of these algorithms have been here for a while. And the two obvious catalysts here are, one, data. Just as an example, 3 billion plus phones with location and camera and all sorts of sensors and usage. And also compute, right, since the 1980s and so on. That's just with GPUs, but of course, the TPUs, et cetera, here, and AI chipsets. So overall, I'd say I'm in the camp of there's something really meaningful and useful happening here. But the future is here. It's firmly and unevenly distributed. So I want to kind of give you a few examples of how AI and ML is used across Google products. This is an eye chart, but I think it's meant to signal or convey this, that there's a lot of usage of these techniques across all sorts of products. Some, on one hand, mature products like Google Search, ads, YouTube, et cetera, but also upcoming products, like if you think about I don't know if you've done that, but I routinely do this, which is hey, search for sunsets or brown hat or whatever in Google Photos, and then up comes those pictures with those specific objects. And Translate is a great example of that. I won't go into all of these details, but I thought I'd give you a flavor of some of the examples here of features that are AI-based, that are making existing products better. So here's an example. This is a feature within Gmail. It's called Smart Reply. And the way it works is, again, there's a ton of labeled responses where you look at existing emails and the responses that are composed in response to the email. And then so we have algorithms that figure out the likely responses you may have to a certain email, especially on a mobile phone where you're kind of with fat fingers, typing is hard, this kind of feature can be really useful. One minor point, nuance here that I want to point to here is that notice that there are 3 choices here, not 1. And again, the insight here is when there's precision recall wise, confidence is you don't have significant confidence and like you don't have a one shot at the answer. You have to design the product, design the UX in a way that allows for those things and allows for user agency, et cetera. That was one of the insights we had from a lot of user studies here. This one I picked because it's a kind of a non-obvious example. What we did was, in our data centers, obviously, like energy efficiency is a big deal. A lot of the energy usage is from cooling. And traditionally, we'd have a whole bunch of heuristics, right? If you had like this temperature, this particular setting, and this particular parameter, then this should be our kind of like cooling pattern. What we did instead is using the help of DeepMind, which is an AI group at Google, we fed all of these parameters into a deep learning algorithm and kind of figured out a cooling pattern, right? We had a generalized approach to it, and it reduced our cooling costs by 40%, right? It's like, the reason I picked this example, it's very unsexy, it's invisible to most people, but I think the interesting thing is a lot of usage and a lot of impact from AI will come from these invisible optimization, right? Taking engines, existing engines, and just making them 10x better because now you have a much more powerful way of like looking at the data you already have or you can collect. So far I've talked about examples where it's making existing products better, right? Be it the Smart Reply, Gmail, et cetera. This is an example of where we're saying, wait, what are new products that can happen because we have these new techniques? Here's an example. It's from a year or so ago. Using deep learning, we're able to detect diabetic retinopathy. So diabetes causes blindness in some of a significant percentage of the cases, severe diabetes. And you can often tell by examining the fundus, right? But the reality is that there's a limited supply of ophthalmologists. There's like human errors involved. Often like it takes 5 to 7 ophthalmologists to like actually come to a consensus on whether it's a diabetic scan or not. What we did was we actually took the help of a bunch of ophthalmologists, had a bunch of, again, labeled images, trained an algorithm, and it's at expert accuracy in detecting whether this particular scan is diseased versus healthy. Again, the reason I chose this example is this is one case where it's probably impossible if you just limit by humans to be able to scale this kind of technology to imagine a town in India where very, very few ophthalmologists exist. The option is not human versus, it is like, basically, going blind versus this. So that's a really useful example. But it's not all kind of the, on the enterprise or in taking these new areas. Many of you on the consumer space have heard about voice-activated speakers, these voice-activated assistants, with Amazon Alexa and Google Assistant and so on, right? And then, of course, we had Siri from Apple a few years ago. This is a case, and it is about building a new product. If you didn't have this step function jump in the quality of speech recognition and natural language understanding, this product is impossible, right? We've had like science fiction movies and like videos talking about it for decades, but it's getting to be tractable and usable only because of these like jumps in the underlying tech here. The thing that also gets interesting in as soon as you start thinking of things like voice and vision is it is not just new products that can be built, it's new interfaces to computing that AI is allowing you. That is, it's one thing to kind of think about a healthcare product that just is built by AI, enabled by AI. But it's another thing to say, oh, now you actually can get computers to adapt to humans versus the other way around, right? If you think about the evolution from like GUI and mouse and even touch and so on, suddenly there's like the learning curve to interacting with computers becomes far lower, right? Again, you can think of this particular example as highly zeroth world, right? Turn off my kitchen lights. But one of the things, again, like the teams found is they just launched a Google Home in India and Indonesia and Singapore, et cetera. And what's interesting there is, again, given literacy and given language, multiple languages, we talk a lot about mobile natives in countries like India and Indonesia where they've never used laptop and mobile's the only computer they know. you're going to see a lot of voice natives, right? Folks who just like grew up saying, of course you should be able to talk to your computer. Both in the emerging markets, but also like those of you who have kids, mine expects to be doing that. I have a 9-year-old. So this is what kind of like, you're starting to change the interface to products and computing through AI. This is, how many of you are familiar with the art selfies thing that Google released? If not, you should totally go check out. It's well worth 5 minutes of goofing off. What basically it is, you take your selfie, and what they do is like look at the catalog of, you obviously extract some visual features and so on, and then match it with there's thousands and thousands of like paintings that exist, right? So in the Google Arts and Culture database. This one's, I don't know if it looks accurate, but at least it's just pretty enough. I'll take it. And on the right side, another kind of like example, right? Which is you take any painting, or even actually a furniture or a blanket or what have you, and then you say, hey, what's the color palette? It just extracts the color palette. It shows you other things that like just match the color palette. Again, kind of seemingly silly and like toyish examples, but you're starting to say and one of the user studies showed that they gave these tools to like kids. They just didn't need any explanation. They intuitively got what was happening here. Because again, it's like removing levels of indirection between you and how you interact with computing. That's frivolous, but there's as vision gets better, computer vision gets better, and computers can start to see, there's a lot more meaningful use cases as well, right? So take this example of, this is Google Translate, but it's working just by pointing to a sign in a foreign language, right? And instantly translating it in any language you need to. So you start to say, okay, actually, that's kind of how you would interact today, except then you have to translate in your mind or like look up and use a tool, et cetera. So again, removing a level of indirection. This is a feature we launched called Google Lens. And again, the idea is the same thing. Can you search what you see? Can you like discover the world around you just by looking and panning and pointing your phone camera at this? And so you just point to this and you know that, oh, this is this ancient Buddhist temple in Kyoto. Where does it all go, right? So this thing that you start to see with AI and voice and vision, et cetera, are the first few steps towards what I think about as immersive computing. Now, that's like a very heavy word to say, but I think what it means to me is, what is the natural, in-context, direct interaction with information? If you think about it, in a while ago, when you had to find out about, let's say, what's Machu Picchu like, what did you do? You kind of like translated in your head, you turned it into a query or what have you, and then like typed it in, you kind of got a rough sense of it. And then a few years later, you say, okay, actually, I can check out a YouTube video, I can like look at images and so on, right? But what does it feel to be there, right? That's kind of the most direct experience. Direct experience is the best knowledge you'd have. And we're starting to see a few steps here. There are also a few landmines, and I'll briefly touch on them. So here's a few examples. If you think about kind of information that people want, questions that people have, right? Some of which, I think, yes, you can still translate and think about it. Some of which is just too hard to describe using text or words, et cetera, right? Especially the thing about like, how does it feel to swim with sharks, right? And then we said, okay, why is this important to Google? It turns out, actually, that's kind of the core mission of the company, right? Like being able to like organize information and make it universally accessible, being able to answer these kinds of questions, any kinds of questions that users may have. So that's kind of one of the driving motivations when we think about, that's our lens on AR, VR, et cetera, if you will, pardon the pun. One way to think about, there's again, like people talk about VR, AR. One simplistic way we think about this is VR. It can take you anywhere, right? It can transport you to a different place or a different experience. It can simulate an alternate reality, let you live a slice of a different reality. AR, you can bring anything to you, right? It can be information around you. It can be objects around you. It can reskin the reality around you. But it's along the spectrum, right? There's a lot of underlying tech components that are the same. They're all trying to solve a spectrum of the same set of questions. So let's briefly touch on VR, right? Again, like, what does it mean to kind of like take you anywhere? And then we've been at it for the last few years. And the way we thought about this, there's obviously like 3 components here. One is, what is the vehicle for consumption? So we started with something, pretty much a toy, like cardboard. And then we said, oh, actually, we can get slightly better in terms of consuming VR content or having VR experiences, but still using a mobile phone. This is where we launched this thing called Daydream View. But then now, like across the industry, there's like a standalone headsets that are starting to become kind of a real, right? There's 6-stop tracking that's improving. Several components are starting to get together. Does that mean it's here? Again, hashtag Cardi B. No, not really, right? The fundamental thing we are seeing is that there's a difference between like kind of subscale, hey, there's something here, there's a few sparks here, versus an at-scale next-generation computing platform. There's a big gap here. We are starting to see some sparks here, right? So for example, like when we have this app called Expeditions. So it's about these like, rich immersive tours to all sorts of places in the world. And like in just seeing these reactions of like kids in the classroom or folks, putting these VR goggles on, it's amazing. It's nothing like, watching a video or, someone telling you about it. So there's definitely a spark, especially in education and so on. But there are two big challenges we're seeing actually. One challenge is on the content itself. It's really hard and like expensive to make realistic 360 VR video, stereoscopic video. On the other hand, even if you had all the content, what we're also seeing is that at the end of the day, you're putting a computer on your face, right? That's a significant friction. And so the value needs to be like, way more than the friction for users to use this. And that's the other challenge we're seeing. On the content side, if I can geek out for a bit, I think like one of the things we did do is actually said, hey, can we build these like stereoscopic like VR video cameras? Let's have, like this one actually has like 17 cameras. It has an up camera. This is something that VR filmmakers can take. It's like light enough. It's about 8 pounds. So it's kind of like, it started to kind of get the VR content creation going, right? But once you have the images, we also have these algorithms, and this is where vision algorithms like getting better is helping us. We stitch together all these images, like, and then the rendering algorithms, et cetera. And then we said, it's still not kind of the fully realistic presence. And so one of the new things we've been working on, and it's highly like super early, but there's something promising here. It's called light fields. Some of you may be familiar. But the idea, the insight is here, is that for realistic presence, if you're really in a place, near the way the place around you reacts to you as well. That is, the light reflects in different ways when you're with nearby objects versus far away, et cetera. So how do you kind of recreate that? What kind of advanced algorithms can like reproduce that, et cetera? So this is kind of like this is what you would see in a VR device of these light fields view of a room, right? It's very, very, very like realistic. This is like one of the examples of people trying VR goggles on and going a place and really getting excited and just like almost like, can you even do that? We also see some traction on the enterprise side. Again, as like Kanye, our generation's Shakespeare has said this, the world is our office. And there's something to what we are seeing in terms of enterprise and VR. That is, can you actually like, have a screen in front of you? Can you have collaboration? Can you do like training and simulation, et cetera? We are starting to see some traction there. Again, going back to a point that somebody mentioned this morning, versus consumer, this value friction trade-off becomes easier in an enterprise because there's often some like high friction problem that you're trying to solve. There's some direct connection to cost, et cetera. So we're seeing some spark there. So that's on the VR side. I would say early days, seeing a few sparks, but a long way to go in terms of being the next generation computing platform. Now, let's look at the other end of the spectrum, which is bringing things to you, around you. There, we are seeing some surprising elements of promise and traction. I say surprising because a few years ago, it felt like, oh, the future's so far, like this idea of like AR glasses, it's like law of physics, it doesn't add up, et cetera. The twist here is, of course, smartphone AR. Given that, again, like you have like billion plus 3 billion phones, not all of them may be like highly capable of this kind of visual-spatial intelligence in the cameras, but many of them are. And you're starting to see interesting use cases happen here, right? But those of you who have a Pixel probably have seen this. There's a tiny feature called AR stickers, and the idea is that you can have like AR versions of like stormtroopers and donuts and everything in between. Again, like a huge hit with my 9-year-old. But if you think about AR, for us at least, there's a few elements here, right? The first thing you say is, you open the camera, you need to actually sense the world. You need to be able to say, what is it that I'm looking at? So that's why we started saying, oh, computer vision is really critical here. How can you kind of like look at, point your camera at something and say, what is that, right? That's one effort. The second effort is, how do you orient yourself in this world, right? Just like you have maps and GPS, for you to orient yourself at a particular zoom level, are you on the street, are you in this neighborhood, et cetera? But how do you do it in this specific like shelf? You're standing in front of this the cereal box shelf in the retail store. How do you kind of localize yourself there? And we work on something called Visual Positioning Service, VPS, like GPS. And here again, the idea is both geometry-wise, oh, is there a horizontal plane here? Is there a vertical plane here? How are you going here? But also semantic. Is this like a store? Are these like shelves? Are these cereal boxes here, et cetera? So we build that. And the last thing you do, of course, is kind of say, what if you want to put things back into the world, right? You want to augment your world, hence the AR, A in the AR. How do you put 3D objects back into the real world? And this is where we started saying, well, can you actually have an asset store? Can you actually have a database of all these 3D images, be it these silly Stormtrooper stickers or like furniture, right? So you put all of these together, and what do you get? Here's a few examples of what's possible, right? This is an example where you can say, hey, I can reskin reality. I can look at something that's under construction, and I can kind of like pan the phone and say, this is what it'll look like when it's completed, right? And the thing here is, it's not purely information or knowledge, it's imagination, right? Just like VR helps with presence, I think what we're seeing with AR is, like, it's hard for us to imagine a lot, but it's easy for us to see it. So if you can display what you have to see in your brain in front of you, it's that much easier. Right? Here's another example. Now, it turns out you can actually operate an espresso machine. Right? Right? How do you kind of display information contextually in situ on top of something that you're manipulating? So that's possible now. You can also, just for the sake of it, put random things like Android figurines in the real world on top of icicles, just because, right? But more seriously, like if you think about other objects, what can you do? You can actually put a grill in your backyard and see how it feels. You can get inside a Porsche, like real life scale, see if it fits in your driveway, because clearly that's the most important. That's the only thing that's stopping us from getting one. And then you can also see, this is a really nice example from how eBay is using AR Core, our underlying tech, to figure out, it's a real problem for eBay sellers. They look at the stuff that they need to ship and say, what size package do I need, and get that done. And like now you can kind of get that visual-spatial assistance, right? This is a brief kind of run through of some of the things that are possible. There's, given that it's an open source, open AR platform that we just like released for developers, I think there'll be thousands of like, AR flowers that bloom, and it'll be interesting. I want to close with a couple of thoughts here that, at least I certainly think of, some of the teams think about, and it might be interesting for you folks to think about. One is, newsflash, it's a long journey. The tech is really hard. This is just one example. And one part of the tech, right, computer vision. It is really hard to tell a blueberry muffin and a chihuahua for some of the systems. I said this at an event when we talked about our products a few months ago, and then 3 months ago, my team sent this picture back to me. Is it? We nailed it. This is a chihuahua, this is a blueberry, at least it says it's blueberry. And I was like, yep, it is. And then sent back another image. It's still hard to distinguish a puppy from a bagel. Sorry for those of you who had a bagel this morning. But, and then of course I said, P.S., it's called job security. It'll be a while before we kind of get the tech to a point that users intuitively, without cognitive friction in their minds, trust these systems to just work, right? With voice, with vision, AR, VR, et cetera. And so meanwhile, what do you do? And this is one thought. Ooh, that kind of messed up. But think about in the process of kind of building these systems, how do you build the UI that's in proportion to the confidence that you have in AI? That is, how do you kind of build, how do you translate precision recall into product principles, UX, and actual real pixel design, right? This is a very tiny example, but you said, hey, this is one of the examples where you can point to a plant and say, hey, what is this plant? Sometimes you're like, nailed it, this is a rose. Other times, like, it could be one of these, right? Because the confidence in the precision recall is at that point in the curve. Also, like, note the gratuitous use of like a random symbol because it's an MIT conference. So with that, I'll end. And one thought, again, is AI is being used in many products, many areas, problems, spaces. It's often used to improve, make the existing solution that much better, where there's already a product market fit, right? It's also being used to kind of start to rethink or think up new products because it wasn't possible with previous state of tech. And specifically, there's a subclass of products I think about where you're starting to use AI, especially voice and vision, almost like define a new and more intuitive interface to computing, and it's really promising. It's a long journey, remember the Chihuahua, but it's very exciting. The first few steps are here. Thank you.